Okay, in previous video, we have seen the conversion of steps to millivolts. Now, why do we need millivolts? So before that, we are going to learn one new sensor. Its name is LM35. So let's see what is LM35 and how we are going to interface it. Okay, so let's go here. Let's search for LM35. Okay, now here you can see the description. Precision centigrade temperature sensor. Okay, its range is from minus 55 degrees Celsius to plus 150 degrees Celsius. And here you are going to have multiple packages. So the package we are using is this one. Okay, TO90-100. So this package we are going to use. Okay, so while doing schematics, you don't have to bother about the package. Okay, so now the work of this IC is to provide the temperature in degrees Celsius, that is centigrade, and it is very accurate. You don't need to do external calibration for this sensor. Okay, it is pre-calibrated properly. Okay, so we are going to use this sensor. We are going to put it over here. After this, again, we have to provide the power supply. That should be 5 volts. Okay, now here we are providing 5 volts and the ground. Okay, I'll save this. Okay, now currently we are having this code, that is millivolts. Okay, now if I build it again, let's rebuild it again, and if I run this, what I'm getting values in millivolts something. Okay, now I want to calculate temperature from this. I want to calculate temperature from this. So how to calculate the temperature? I'll come to know what is the temperature and how, what is the response of the LM35 and how I can calculate the temperature from this voltage. We are getting the voltage in the form of millivolts. For that we have to refer the data sheet of LM35. Okay, so you have to go through the data sheet. Okay, here they are given the adjustments, whatever you want to uh, perform, how to do the interfacing. They have provided the various packages. The package we are going to use is T092. See here it is mentioned over here also. Okay, so right now we don't have to bother about anything else. Currently we have to do the circuit diagram. So in circuit you can see that it uh, it can take minimum 4 volts. Okay, so that's why I have provided 5 volts to this. Okay, at max it can go up to 20 volts. Yes, and the output. Okay, now how we can calculate the temperature. So here they have mentioned that this IC is going to provide 10 millivolt for each degree Celsius. Suppose our IC is at 0 degree Celsius. In that case, it is going to provide us 0 millivolt, 0 volts. If the temperature is 1 degree Celsius, if we are having 1 degree Celsius temperature, in that case, it is going to provide 10 millivolt. If the temperature is 2 degrees Celsius, it is going to provide us 20 millivolt. Like that, it is going to go on. Okay. If you want to go in negative or minus, so you have to do these settings. Okay, so you can read the data sheet and you can do the calculation for this. Calculations are not that much complicated for this sensor. Okay, if you use NTC, PTC sensors are there. For that you have to do lots of calculation, formula for slope and all that, but there is no need, such need in the case of your LM35. It is pre-calibrated. Okay, so what we came to know from the datasheet, it is going to provide 10 millivolt for each degree Celsius. Now what we have to do, we have to do same updates in our code accordingly. So let's jump to the code. Now we are having already the millivolts. So now what we need to do, we have to declare one variable. Now your temperature is not going to be an integer value. Okay, it will be a float or decimal value. like 27.8, 30.4, like this. So here we are going to write float, declare float, Celsius, let's put initial value 0 in this. Okay, done completely. Now what we have to do, we have to introduce another formula to calculate the Celsius. Cell is equal to, what our data sheet is telling us, that we are going to have 10 millivolts per degree Celsius. We are going to have 10 millivolts per degree Celsius. So in this case, what we have to do, we have to just write a small formula. Okay, let's put the code. So here your voltage, that is voltage MV divided by 10. Yes. Okay. Now there is a problem with the STM that you have to do a little bit of settings that we are going to see later on. Now what I am going to do here, instead of millivolt, what I am going to pass, I am going to pass this Celsius. Okay. After this, now here we have to do a little bit of changes. So this is for long unsigned. So now we are dealing with the decimal point, that is floating point. So here, how many digits I want to show after the decimal point, and here I am going to provide the 1f, that is I want to just get one digit after the decimal point. Instead of MV, now here we have to mention the degree Celsius. So I don't know how to put that degree symbol, so I'm going to put just a single quote, and this is the degree Celsius. Here what I'm going to do, so voltage, I'm going to write temperature. Okay, now let's build this code. Yes, let's build it again. Okay, now we have to do one important setting. Okay, so you have to provide the float support. So you have to click here on add, and you have to add this line. Yes, print f float for conversion support. Okay, apply, rebuild the index, apply and close. Okay, so let's build this again. Okay, otherwise later on you are going to get warning for this line. Here you are doing the conversion. So for SN you have to provide support for floating point numbers. So for that you are going to get one warning over here. So to avoid that, so overcome that warning, we have to add the flag over here. Right click, I'll show that path again. So in miscellaneous, you have to add this one and delete the other one. So hyphen u printf. So you have to add this flag. Apply and close. Repeat the index. Let's build it. Let's get back to the Proteus. Let's run this. Okay, so we are getting 27.0 degrees Celsius as we were expecting according to our formulas. Now if we increase the temperature, it is good to go. You can provide 5 volts over here because it will go up to the, I can say, 1.5 volts only at max. It is not going above 1.5 volts for 150 degrees Celsius. Okay, so this is how you can calculate the temperature. What you have to keep in mind, the data sheet, any sensor you are using, any IC you are using, you should refer the data sheet for that. Don't go for YouTube tutorials. You don't need to search online. Simply go through the data sheet. That is the practical way of doing the things. Okay. In next session, we are going to do the same on the hardware.